Here we're asked to find the value of a log without a calculator. And a couple things that we need to know about logs in general. We'll start with this first one to kind of explain this. When we're trying to find the value of a log, we're saying that if we were using a calculator and we plugged in, log base 5 of 25, well, what would we get out of the calculator? What's the value of it? And the way to find that without one is we're really just looking at this base here. We can kind of change this log equation into an exponential equation saying like this base 5 to the power of what, that's what we're looking for, is equal to 25. So again, this one to start is a fairly straightforward one because we're just saying, okay, hey, I know that 5 squared is equal to 25. So my value of this expression is 2. So we can find the value by kind of thinking of it as what is that exponent that would make this true? Now, what really helps us in these situations is understanding our exponent rules. So I understand, 5 squared is 5 times 5. Now, when I look at this next one, log base 9 of 1 over 81, in that one here, we're saying, okay, 9 to the power of what equals 1 over 81. Now, one thing to help us is it's good to know that if we're looking at this as a fraction here, to start from 9 and get to a fraction here, I can tell pretty quickly that I know 9 squared is 81. But to get it as a fraction, to get the reciprocal, we're going to need a negative exponent. So in this case here, it's got to be negative 2, because if I have 9 to the power of negative 2, that's the same as 1 over 9 to the power of positive 2. And 9 squared is 81. And so the value of this log, when I go back to my original problem, is just negative 2. Next one, we're going to use another exponent rule here when we're dealing with this one, because I'm saying, okay, hey, 42 to the power, so that 2 is bad, 42 to the power of what is equal to 1. And one of the rules that we know about exponents is that something to the power of 0 is always going to be 1. So if it was 565 to the power of 0, that's still 1. No matter what the base is, when we raise it to the power of 0, it is equal to 1. So anytime this number on the inside is 1, I know my answer is going to be 0 here, or my value is going to be 0. Now these last two are a little bit tougher here, so we got to use a couple of steps before we start thinking about our exponent rules. First of all, I'm going to go ahead and rewrite this as an exponential equation. So square root of 5 to the power of something equals 125. That's the best way to kind of look at these things. Now, as a rule, to help us with this, what we can do is we're going to have our left and our right side come up with something at the same base. So our exponent here, we're going to have a base that is going to be the same with an exponent over here that has the same base. Something that I can see in common between these two things is 5, meaning I know, the square root of 5 is equal to 5 to the power of 1/2. So I just changed the square root of 5 here into 5 to the power of 1/2. I'm still trying to find this exponent right here. I'm going to use x as kind of a placeholder because I'm, looking for a value that goes there. So I have 5 to the power of 1/2 to the power of x. And again, I want to have the same base. So I want this to match this number right here. And I want to think about, okay, how do I get from 5 to 125? Well, that's going to be 5 to the power of 3. So my first step is set it up as an exponential equation. My second step is make it so that both sides of the equation have the same base. And then the last step is just use our exponent rules to solve. In this case here, my exponent rule, I know that whatever this times this will give me this here. So I can kind of set this up as another algebraic equation, 1/2 x equals 3, because 1/2 times something is going to be equal to 3 because of my power of a power rule. And now to get that number, I just multiply both sides by 2, and that gives me my value of my original log, which is 6. So I'm going to use that same idea, that same concept to solve this last one. First, I'm setting it as an exponential equation. So 4 to the power of something, I'm going to go ahead and use x, equals 2 to the power of 5. Second step, I need to find something with the same base. So I know that 4 is the same thing as 2 squared. So I'm just changing 4 into 2 squared, and now I have the same base. And now I'm using my power of a power rule to tell me I know 2 times whatever that number is going to be 5, which tells me that my value is 5 over 2, or 5/2. So again, really understanding the fact that when we're dealing with logs, we're taking the base to the power of something gives us this value here. And then using that along with our exponent rules to help us find what those exponents are going to be.